Jane is investigating the relationship between two sets of data labeled P and Q that she collected. She created a scatter plot with the P on the x-axis and a common log of Q on the y-axis. Jane noticed that the points had a strong linear correlation, so she drew a line of best fit as shown in the diagram. The line passes through the points 0, -1.3, and 6, 14.9. Find an equation for Q in terms of P. P and a common log of Q. This is the semi-log. Semi-log means the relationship between these two variables is exponential. Since we are given 2 points, we need to draw the table x, y, x, y. This is x, this is y. X is P, y is the common log of Q. 0, -1.3, 6, 14.9. Let's find this linear regression line. Type the data into column A and B. Then go to menu, go to 4.1. Linear regression line 3. X list is A, Y list is B. We already saved this regression equation to F1. Okay. Linear regression line pattern is mx plus b. M is 2.7. B is -1.3. So we get y equals 2.7 x minus 1.3. Y is a common log of Q equals 2.7p minus 1.3. For the semi-log equation, common log of y equals mx plus b. This m will be the exponent, and b will be changed into 10 to the power of b as a coefficient. So we got y equals, base is 10 to the power of mx times 10 to the power of b. So go back here, q equals 10 to the power of 2.7p times 10 to the power of -1.3. We need to change this into constant. 10 to the power of -1.3. Answer is 0.0501. So Q equals 0.0501 times 10 to the power of 2.7p. Jane also investigates the relationship between the same data Q and some new data R. She believes that the data can be modeled by Q equals A times natural log of R plus B, and she decides to create a scatter plot to verify her belief. State what expression Jane should plot on each axis to verify her belief. Variable Q on y-axis and natural log of R is on x-axis, so that you can get this linear function. The scatter plot has a linear relationship and Jane finds A equals 4.3 and B equals 12.1, which means Q equals 4.3 natural log of R plus 12.1. Find an equation for P in terms of R. From question A, we already got Q equals 0.501 times 10 to the power of 2.7p, or common log of Q equals 2.7p minus 1.3. Which one you got to use to figure out this P? Let's analyze. For the equation 1, P is exponent. In equation 2, this P is in a linear format. It's easier to figure out P by using equation 2. Let's do the substitution. Q equals this. So we substitute 4.3 natural log of R plus 12.1 for this Q. We got common log of 4.3 natural log of R plus 12.1 equals 2.7p minus 1.3. Let's add 1.3 on both sides, then divided by 2.7 to figure out P. We got P equals common log of 4.3 natural log of R plus 12.1 plus 1.3 over 2.7. This is a P.